All right, this one, I just can't leave it this way because it's got a radical in the denominator. So how do I go about fixing one like this? Conjugate. What is the conjugate of this? So I'm going to have to do that same thing in the top because we know that that's really a 1. Okay, so in the top, when I when I distribute this one here, I'm going to get 20 square root of 7 minus 25 over, now down here, I have to FOIL this. What is 4 square root of 7 times 4 square root of 7? Probably. 16 times 7. I'll take your word for that. Okay, 112. I don't want to think that hard. Okay, so I get that. What is 4 square root of 7 times negative 5? Negative 20 square root of 7. What about when I go 5 times 4 square root of 7? Positive, so those are going to cancel, right? So I don't even need those. And then I get 5 times negative 5. Okay, so 112 minus 25 gets me down to 87. And then the top is this ugly thing. But at least I don't have a radical in the denominator. Does a 20, a 25, and an 87 have anything that I can cancel? No. 8. Okay. Well, I have a radical in the denominator. It's kind of a problem. But I'm not adding or subtracting anything down there this time, so I don't need a conjugate. I just need to multiply the bottom by something that's going to get this to not be a radical anymore. So, is 5 a perfect square? So, like, will that square root cancel it out? No. So what should I multiply the 5 by in order to get it to be a perfect square later? A 5. Is x squared a perfect square? Yeah, so that one's actually okay, because the square root was going to cancel that one out, so I don't have to worry about that. How about y? No. So what should I multiply it by? A y. But if I do that in the bottom, I got to do that in the top. So what I'm going to get down here in the bottom, I'm still going to have this 9 down here. And then I'm going to have the square root of 25 x squared y squared. And in the top, I'm going to have this 4 out in front. And I'm going to have the 2 times the 5, so square root of 10 x y squared. All right, so let's look at the bottom. All right, so I've got that 9 out in front. Now, what is the square root of 25? 5. So I have that 5 times that 9, so I'm going to have a 45 down there. What's the square root of x squared? Square root of y squared? Okay, so that's my denominator. Now, in the top, I've got that 4 out in front. Is 10 a perfect square? So it has to stay under there. How about x? How about y squared? What is the square root of y squared? Y. So I get this y out in front. And then I still have that square root of 10x trapped in there. Can I do any simplifying? What gets to get canceled? So I'm going to have 4 square root of 10x over 45x. What do I do on this one? Foil it. And what do you notice about these two terms? They're conjugates, so I'm going to get some pretty serious canceling going on. Well, they're supposed to be conjugates if I would have copied it right. Pretty sure I copied it right now. Okay, now it's better. All right, now they're conjugates. So when I FOIL this, what is the square root of 5 times the square root of 5? 5. What is the square root of 5 times negative 2 square root of 3? Negative 2. Right. And then when I go 2 square root of 3 times square root of 5, okay, which is nice because those cancel. Then I'm going to have, what am I going to get here? Because I'm going to have my 2 times the 2, which is 4, and then it's times the 3, so I'm going to get 12, and it's negative. Good. So all in all, these canceled. So 5 minus 12. Negative 7. Yep,
Don't you multiply the 2's together?
I did.
Oh. No, because the 3 stays the same and it doesn't become a 6.
Right. Does that make sense to you? Okay. Because I had to go 2 times the 2, I get my 4. But then square root of 3 times square root of 3 is still 3, not 6. Yeah, otherwise it would have been 24. Good. Any other ones? Okay. For me, I always thought of these problems as being like you have to break them down into like the good stuff and the bad stuff. Okay. So I'm going to end up factoring this into perfect fifth roots and then all the leftover garbage. Okay? So the first thing we want to do, we're just going to go left to right. Is 5 a perfect fifth? No, it's not nearly big enough to be a perfect fifth. The first one we know is 32. So 5 isn't big enough. So it goes in the garbage pile. Right, now, is a to the 5th a perfect fifth? Yes. All right, so it's good, so it gets to come over here. Is b to the 9th a perfect fifth? No. All right, now here's the weird part. When you have these variables, is there a perfect fifth in it?
Yes.
What is it? B to the 5th. What will that leave me left over with? So the b to the 4th is the junk. Right? How about c to the 13th? Is it a perfect fifth? Is there one in it?
Yes.
What's the biggest one? Leaving me left over with? Okay. So then we simplified this part. So what's the 5th root of a to the 5th? What's the 5th root of b to the 5th?
B.
5th root of c to the 10th?
2.
And then all the junk. You got a bunch like that. You can handle those?
Yeah.
I don't. Our homework didn't look exactly like that. One of those problems kind of looked like it, but they're going to look more like this. Right. So if it's a perfect something, put it in the left. If it can't, or you have leftovers, throw them in the right. Simplify out the left stuff, and then just tack on the right. Okay. As it stands right now, you cannot put these two things together because one's 14 square roots of 20, and the other one's negative 3 square roots of 125. They're not the same type of root. So, but they're not simplified either. So I want to try to factor this one down. So what can I break the square root of 20 up into?
4 and 5.
What is the square root of 4? 2. And I already had a 14 out here. So 28 square root of 5. Right? Any perfect squares in 125? 25 and 5. What is the square root of 25? And I already had this 3 out here. So now once they're simplified, can I put them together? Yep, so I'm going to have 28 of these minus 15 of those. Total, left over, 13 of these. Right? When in doubt, if you get to this point and you're not real sure what to do, radicals always behave like variables. So think about what you'd do if they were variables. So since these are the same, this would be like a 28x minus a 15x. Well, we know that would be 13x. But it's not an x, it was a square root of 5. So then you back substitute. They behave just like variables do. So in the same way as if I had 28 square root of 5 minus 15 square root of 3, those are not the same, right? So how is that like a variable? That's like a 28x minus a 15y. They're not the same, so you can't put them together, right? So it's the same thing with roots. If they're not the same, you can't put them together. So when in doubt, always think of them in terms of variables. Whatever you would do with variables, because you guys are pretty good at those, you would do the same thing to the radicals. It works the same way when you guys are multiplying. So if you go 3 square root of 2 times 4 square root of 3, right? Think about that. If I had this in variable form, it'd be 3x times 4y. What do you do with that? You multiply the coefficients, and then you multiply the variables. Right? Up here, I'd multiply the coefficients, and then I'd multiply the variables. What's square root of 2 times square root of 3?
Square root of 6.
So you're allowed to put the coefficients together, and you're allowed to put the radicals together. Same thing down here. You're allowed to put the coefficients together, you're allowed to put the variables together. Right? So they always behave the same way. Anything else? Do you want to see more like this? I have a couple more if you want to see them.
Okay.
You're okay? Anybody else? Alrighty. Alright, looking at quiz on 7.1 through 7.3 tomorrow. My suggestion would just be to kind of look back over the homeworks, and the problems are going to look just like those. Alright.